Hi, I'm Bob Helsel from the IVI Foundation. Welcome to the IVI Getting Started Guide videos. Our purpose is to provide you with an easy tutorial on using IVI drivers in the development environment of your choice. After a brief introduction, a technical expert will show you how to use drivers with your ADE. First, I'd like to go over a few key benefits in using IVI drivers. They will save you time in your program development. Number one is interchangeability. IVI drivers enable the exchange of instruments in your system with minimal code changes, reducing time and effort. Two, ease of use. You can use your favorite ADE such as Visual Basic, Visual C++, LabVIEW, LabWindows, MATLAB, or V. The standard APIs provide fast, intuitive access to functions. Three is quality. You'll have common commands and desirable options. The Foundation's rigorous testing ensures driver quality. Four is simulation. Simulation allows code development and testing even when an instrument is unavailable. We'll be taking advantage of the IVI simulation feature as not all viewers will have this hardware available. Fifth is performance and reliability. Examples of these are capabilities such as range checking and state caching. These are some of the key features of IVI drivers that will cut your program development time. In order to follow along with this tutorial, you'll first need to download and install an IVI driver. There are two ways to do that. You can go to the driver registry page on the IVI website, or you can go to the instrument vendor's website. Find the 34401A driver, download and install it before taking the tutorial. Now let's go to the product expert for your ADE.
Hello, and welcome to the IVI Getting Started with Visual C# and VisualBasic.net. My name is Deborah Homan from Agilent Technologies, and I will walk you through an example to demonstrate just how easy it is to use an IVI driver in these programming environments. In order to follow along with this example, you'll need to download the software listed here. For assistance with finding and installing the software, please refer to the IVI Getting Started Guide on the Resources page of the IVI Foundation website. Now we'll get started. First, we'll create a new project and reference the driver. So we'll begin by launching Visual Studio and creating a new console application in Visual C#. Note when you select New, Visual Studio will create an empty program that includes some necessary code, including using statements. Keep this required code. Next, we'll want to add a reference for the driver that we're going to use. We'll select the COM tab since we're using an IVI-COM driver for the Agilent 34401. This example uses an IVI-COM driver as it's the preferred driver for C#, but IVI-C is also supported. And now you can see with the reference available, we have all of the instrument capability and commands that we can reference in our program. Next, we'll create an instance of the driver. To allow the program to access the driver without specifying the full path, we'll type the following command. Note that as soon as you type the A for Agilent, IntelliSense lists the valid inputs. Once we've done that, now we can write the main constructs for the program. We'll create a variable to represent the instrument and then set the initialization parameters. Again, note that IntelliSense helps ensure that you use the correct syntax and values. We created the variable. Now we'll initialize the DMM. For this example, we won't use an actual instrument. We'll use the driver in simulation mode. So we'll set up the GPIB address, and then we'll set simulate to true. And again, as you type, IntelliSense provides supporting documentation for the commands and what the parameters are and what correct parameters. Now we'll configure the instrument to take a DC, to set up for a DC voltage measurement. We'll set the range to 1.5 volts and the resolution to 1 millivolt. Next, we'll set the trigger delay. We'll set it to 0.01 seconds. Now we'll set the reading timeout and display the reading. So this triggers the DMM and sets a timeout. We'll type the following for the right line. The measurement is 0. Followed by a read line. Next, we'll have to close out the instance of the driver to free up resources. This is a very important step. Now that we've completed the code, we'll build and run the application. And you can see the measurement is 0. Everything worked. The code for Visual Basic console application in Visual Studio 2010 is almost identical to the C# application. I'll open up an example and show it here. The main differences include the following. To use Visual Basic, select Visual Basic and project types. To enforce type checking, insert a line at the start of the code, which you can see here, option explicit on. This example also shows how to set an enumerated property. And then finally, to dimension a variable for the instrument and reading, use dim DMM and dim reading. We'll do the same thing and run the program, and you can see everything worked, no errors. Thank you for watching this video. This concludes the IVI Getting Started for Visual C# and VisualBasic.net. For more information, please refer to the other videos, tutorials, and documentation found on www.ivifoundation.org, as well as the other websites shown today. Thank you again for your time. This concludes the video.